Okay. Sorry, guys. I forgot to record. But, you know, we just got through the first example, so I'll backtrack here. We talked about the difference between an indefinite integral versus a definite integral. And the difference is, if you want to pause and write all this stuff down, in an indefinite integral, you don't have limits of integration. So you don't have numbers that you're going between. In a definite integral, you do. So like example down here, we have no limits. Here we have yes limits, all right? So the first one is just asking for the general antiderivative. It's x cubed plus c. If we take the antiderivative of that guy, here they want me to, yes, take the antiderivative, but then I plug in 0 and 4, and we got 64 as an answer, okay? I drew this little graph right here because that's what 3x squared kind of looks like-ish, and that means this area right here from 0 to 4 is 64. At the top here, I said taking the antiderivative is the same thing as integrating, is the same thing as evaluating the integral. Any of those words all mean find the antiderivative. We did example 1. We said the derivative of 2 was, antiderivative of 2 was 2x. Then we plug in, I use this little notation right here, this little bar, saying that I found the antiderivative, but I haven't plugged my numbers in yet. And we plug in 4, then we plug in 2, and we subtract them, and we get 6. Okay, so I know that was really fast, but let's go through part B. Part B is a linear function, and we want to find the antiderivative. Here we go. Eli, you best be listening to this, kiddo. Okay, like, and write stuff down. Okay, x plus 2. What's the antiderivative of x plus 2?
1/2 x squared
Plus 2x. Okay, and then I do my little bar, and I'm going to put parentheses, and I say -1 to 2. Okay, we plug in the top number first.
6.
So I'm going to do 1/2 times 2 squared plus 2 times 2 minus what I get when I plug in 0. Now, the really nice thing, and I, oh, no, -1, sorry. I lie. Okay, never mind, I won't tell you that yet. All right, 2 squared is 4, half of 4 is 2, plus 2 times 2 is 4, which is 6, yeah, minus -1 squared is +1, so this is 1/2, minus 2, 1/2 minus 2 is -1.5, right? But then I have an extra negative there, so that's going to make that plus 1.5, yeah? So 7.5 is what you get, or 7.5-ish, whatever. Got it? We know what we're doing, I think. Okay, what about C?
We gotta put him to the half power first. No?
Yeah, this thing's to the half power. But then we have like the chain rule thing going on. Right? I don't think we can because they're both underneath of the square root. Like if it was just 1 minus x squared, we could do antiderivative of one, antiderivative of the other. So I don't think you can do that.
So we just scribble it out. It says he makes a half.
Gross. Okay. All right. We can do the u thing. It's going to be really ugly. All right. Are you ready? Woo, u. All right. U is?
1 minus x squared.
I don't like this. All right. We'll see how far we get. This is really disgusting, and I don't know if I want to do this. Du is?
X.
-2x dx. Yeah?
How?
-2x dx. I don't like this. We're going to end up with a dead end. Do we have a crazy antiderivative for 1 minus x squared? Is it like a trig function? Yeah, is it? Ah! Okay. Yeah. Yeah. The square root of 1 minus x squared, I don't know.
Do we want antiderivative?
Yeah, does he come out nicely? We have a perfect antiderivative of the square root of
The
1.
inverse sign is 1 over square root of 1 minus x squared.
The inverse sign, I gotta find it. Where are we at? Oh, is 1 over the square root of 1 minus x squared. What are we gonna do? Yeah, inverse sine is, yeah. But
So we
that's,
just have 1 over inverse sine.
yeah. Right?
I don't know.
Yeah. Yeah.
Like I'm asking you.
Yeah, I know.
Or can it just be sine?
No, I like your idea. Let's go with your idea. I like that better. So, okay, the deal here is, the thing that we're looking at is the antiderivative of 1 over 1 minus x squared. I'm just rewriting this down. Is inverse sine, right? But we have just the square root of 1 minus x squared, not 1 over 1 minus x squared. So, basically, in a sense, we have 1 over this junk is what we have here, right? 1 over 1 minus x squared is just 1 minus x squared, right? Because he keep flips to the top. So like this guy would end up being 1 over sine x, inverse sine x, yeah? You see how that works? That's what he is. Okay, so, yeah, okay, so this comes out not very, not too bad. 1 over inverse sine is what he of x, is what he comes out to be, and then we have 0 and 1. Okay. Okay, do we want to be in radians or degrees? I'm
I don't
wondering.
know, we can't divide by 0, so that doesn't work.
She's right.
Mm.
Okay, wait, but if you take the.
Wait a second. This is what he looks like right here. The square root of 1 minus x squared. He's like a semicircle. Or like a quarter of a circle, actually.
I'm sure if you found like other, if you went back, you would see him making more of a circle all the way around.
Yeah, he makes a circle all the way around. Like, he would.
So then it wouldn't be until
So it would be a quarter of that circle.
maybe like at -2 is where he ends.
I'm just thinking of what the answer would be. Like, the area of a circle is pi r squared, right? But the radius here is 1. So the whole area of that whole circle is just pi, right? But since we're only doing with a fourth of it, the final answer should be pi over 4, true? Right? How do we get pi over 4? As a thing.
We must not be able to use that equation.
I know, I wonder if inverse sine is not the right. And we would have to like redo him, yeah. I don't know, let's skip to the next one and I'll come back to it. I'll have to look into him. Can I look into him later? Okay, let's do it.
How much is left of this? Is this a packet?
This is
Is a page?
it's just a page. It's 2 pages.
Yeah.
What if x squared minus x?
Yeah, okay, example 2. Well, yep, Reese got it. 1/2 x squared minus x. Is my antiderivative, plug in 2, plug in 0. B is the same thing, except we're plugging in 1 and 0 instead. Which one should have a bigger area?
The top
The
one.
first one? But that first one doesn't have an area though. He's a line. I'm kidding.
No, I'll show you. Let's see what he looks. Oh, I forgot to put the picture of what he looks like. Or maybe I didn't. I'll show you what he looks like here in a second. So if we plug in 2, we've got 1/2 times 2 squared minus 2. That guy
Is 0.
minus what I get when I plug in 0. So 1/2 0 squared minus 0. This guy's 0. Okay, this guy is half of 4, which is 2. 2 minus 2 is 0. 0 minus 0. So you're right. He comes out to be an area of 0. How can you have 0 for an area? What the heck?
There must not be anything there.
Okay, so here's the deal. This is how this works. X minus 1. If I graph x minus 1 as a linear function, he's down here at 1, yeah? At -1, and he goes up 1 over 1, up 1 over 1, okay? So this is 1, this is 2, and here's where my function goes, and I'm trying to find the area in between here. Now, so I'm looking at this area bounded here and this area bounded here. This is a positive area. This is a negative area. And they do cancel each other out, right? Now here, if we're going from 0 to 1, we're gonna end up with a negative area. I'm gonna guess it's gonna be like negative half, right?
That's
Okay, so if I'm just going from there to there, 1/2 x squared minus x, plugging in 0 and 1, yeah, 1/2 times 1 squared minus 1, and then minus, we know when we plug in 0, it ends up being 0, because we got it from over here. Okay, so yeah, 1/2 minus 1, negative half. And so you can have an area that is negative. It's just because he's below the x-axis. So whenever you're finding area, you're finding it like bounded to, whatever area bounded to the x-axis, right? Even if it's below, you're finding that area that's up to the x-axis. If it's above, you're finding that area that's down to the x-axis. And because that's kind of like a little bow tie thing, the areas are going to cancel each other out. I had that picture saved on my computer, and when I cropped it over, it must not have saved. But anyway, all right. Good? Happy with that? There you go. Properties of the definite integral. Here is another little thing. This picture goes with this guy right here, this first property that is part A. Look at what they have going on here.
Hang on.
Squiggly.
Oh, it's on the front.
This is on the front still, at the very, 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 very bottom. Okay?
Oh, then I did
Look
this
at this right here. If you're going from A to A, okay, these tell you where you're starting and where you're ending. Okay? So imagine like finding areas like taking a slice of bread. Like usually we're going from like, I don't know, like 0 to 4, or 0 to 2, something like that. And I'm taking a slice of bread that's two units wide. Here you're going from A to A, so you're going from like 2 to 2. So I'm trying to take a slice of bread that has no width. It's kind of like what we did in stats, right? You're trying to take a slice of bread that has no width, so its area is going to be 0. That should make sense, right?
Yeah.
Why would they have you do that? I have no idea. But if your A and B value are both the same number, just know that you're trying to take a slice of bread that has no width, okay? Now, every once in a while, they will do this to you where they have you do like a function that is like going from 4 to 0 instead of 0 to 4. Like doesn't go in order, okay, of your function. And what you can do is instead of doing that, that is the same thing as 0 to 4 with a negative in front of it, right? It's just going to represent negative area. It's like you're reading the area from right to left instead of reading the area from left to right. It's going to be a negative area. Got it?
Yeah.
Weird stuff, okay? So just so you know, the B and A can flip-flop, but the area is going to be negative
Okay, well, they're making.
of what it was before.
For that example, they're making us do the one that we couldn't figure out.
Yeah, she's right.
What the heck? Okay, I'll look in my book. Let's do, oh, A,
That's easy.
0. Whoa.
0, because 1 to 1. Like, you're taking a slice of bread that has no area, so 0. Let me get the book out and see what they're doing for that one. I think there's something very obvious that I'm missing, because they've given it to us twice now. And where is my book? Let's see. Yeah. This is
Did you
5.
intentionally tape over this little guy?
Is this 5-5? Whew, man.
Did you
How far are we?
intentionally do this?
What?
Tape over your stuff?
No. I just needed to put him up there. Okay, how did they do it?
What is day rotations in? Lawrence Nelson?
What? This is crap. Yeah, it really is.
Show us.
They didn't even solve the thing. They just
Cheater.
sketched it. Oh, I think hold on. Example 1. The problem is you can't just do the straight antiderivative. They just say, sketch the region whose area is represented by the definite integral and evaluate the integral using geometry.
I don't like geometry.
So they did it the way that we did it, like right here. They said, here, it's a quarter of a circle when you sketch it, which means the area is going to be pi over 4. Yeah.
Interesting.
We wouldn't be able to do the whole sine and cosine and tangent thing or whatever.
So now
Like,
what are we supposed to do with this one then?
so with this
We know
one,
we know what's
this one we know that from 0 to 1, the antiderivative of this guy from above is pi over 4. So if we're going from 1 to 0, we're reading that area like kind of backwards, I guess. So he's just going to be negative pi over 4 as an answer.
Okay,
Right.
that makes sense.
Yeah.
Okay, let's
That's
figure out the next
ugly.
one.
What the heck? They didn't even give us a formula for it.
Pi over 4.
Yep. Okay, now, they didn't have an example that I really liked that went along with this next concept, so I wrote my own. So here we go. We're going from A to B of a function. And what we are allowed to do, like let's say we're going from 0 to 4 of a function, right? What I can do is I can separate those into pieces, and I can go from like 0 to 1, and then I can go add that to the area from 1 to 4, right? I'm just adding areas together, right? So if I want to find the area from 0 to 4, I could find the area from 0 to 1 and add that to my area from 0 to 4, right?
have a question.
Or I could go 0 to 2 and add that to 2 to 4, right? I can separate that area out and just add those two chunks together. Yes, dear?
Why are we separating them and not just doing
Because
it?
it's after the value,
Now.
it's gonna be a tippity tip.
Absolute value is going to have a tippity tip.
Got you.
Okay, and so here's what he's going to look like. This absolute value guy is at x minus 2, which means he is to the right 2 units, and then he goes like this, right? That's what he looks like. He's a V, and he goes to the right 2. And I wanted to find the area from 0 to 5. Okay, now I could do that using algebra if I wanted to. He's like 2 little rectangles put together, but I don't want to do that. So here's what I'm going to do instead. I don't know how to take the antiderivative and absolute value. Okay, so here's what I'm going to do instead. I'm just going to look at this as 2 separate functions, and I'm going to chunk him right here in the middle, and I'm only going to find the antiderivative from 0 to 2, and then I'm going to add that to the area from 2 to 5. Okay, do you see why I chunked him from 0 to 2 and 2 to 5?
Yes.
Okay, now, this guy right here,
Negative x plus 2.
he is negative x plus 2. That's exactly right. So negative x plus 2 dx is what his antiderivative, or what his function is. This guy is the linear function, positive x minus 2
Why?
dx. Okay, do you see the two linear functions?
Yeah, I see that.
This guy is a linear function. He is negative x because he has negative slope, and he's
Yeah.
at 2, right? So negative x plus 2 is his linear function. This
I
guy...
get it because there's an absolute value bar. Okay,
Yeah, absolute
why?
value means you have to negate
Yeah.
everything. So this guy is like case 1, right? You remember when we do cases 1 and 2? This is case 1. The negative of it is case 2, right?
Yeah.
Okay, do you see how that works?
Yep.
So now we're just doing those in bits and pieces, okay? So this guy, we take the antiderivative of him, which is negative 1/2 x squared plus 2x. And then I'm going to eventually plug in 0 and 2, okay? This other guy, his antiderivative is positive 1/2 x squared minus 2x. And I'm going to go from 2 to 5. Confusion?
No.
Maybe I should have just done one piece at a time. I don't know.
No, it's
No? Are we okay? Okay, so this guy right here, we're going to plug in 2, and we're going to plug in 0. And you plug in 2, you get 2, and you plug in 0, you get 0. So this guy's area is 2. Plus, if I plug in 5 and I plug in 2, this one we have to do like a little bit of work. If I plug in 5, 1/2 times 5 squared minus 2 times 5 minus 1/2 times 2 squared minus 2 times 2. Blah. Okay, is 25, half of 25 is 12.5 minus 10. So 2.5 is here minus, this guy is 2. No. 2 squared is 4, half of 4 is 2, minus 4 is negative 2, but then I've got another negative here, so that's plus 2.
2.5 minus 2 minus negative 2.
Yes,
So 4.5.
4.5, but then I've got this other 2 on the beginning of it
Yep.
from this guy.
Plus 2 is
So?
6.5.
6.5 is my final answer for the area. You see how that works? So instead of doing the antiderivative of an absolute value, which I don't know how to do, we can't do it because it has a tippity tip, we separate it into 2 chunks, and I can add those areas together. So like this area was 2, and this area was 4.5,
Yeah.
making a total area of 6.5. Very nice.
Makes sense.
Yep. Okay.
Keep going. We're almost done. We have one last example.
Okay, and I don't know where they get this crap from. All right, next example. We have 2 pieces, this one, right? The 5 and then the minus 3 times that junk, right? So we can write that as 2 separate pieces. I'm going from 0 to 1 of 5 minus going from 0 to 1 of, and check this out, I'm going to toss the 3 in the front because it's a constant and I can do that.
Whoa.
Oh, I need to put a dx on the end here.
And this stupid
1
thing.
minus x squared dx. Yeah?
Yep.
Okay. All right, let's do this, guys. Antiderivative. What's the antiderivative of 5? 5x going from 0 to 1 minus 3. And do you know what the antiderivative of 1 minus x squared plugging in 0 and 1 is?
Sine and
Pi over 4. That was the one
Yeah.
that we, did whatever.
Mm-hmm.
Okay. So if I plug in 1 into the 5, so 5 times 1 minus 5 times 0.
Wait.
Minus-
What, we need our bar with our 0 and 1 on the other guy?
On this guy, I've already plugged him in. We just know that this whole antiderivative after we've plugged in 0 and 1 is going to be pi over 4.
Okay.
Because that's the fourth of the area of the
Right,
circle,
so
right?
that's up top.
Right, so we've already done that part. We've already plugged in the 0 and 1. Make sense? Good? Okay, 5 times 0 goes away. This is 5 minus, 3 pi over 4. I don't know how we can write that together. Probably just 5 minus 3 pi over 4. Or let's just do a decimal.
2.644.
2.644.
Is that the last
Yeah.
thing?
Yeah. Very good. This bottom part just tells you beware of things that you can't take antiderivatives of, because if there's a vertical asymptote or something weird happening, you can't take the antiderivative, right?
And then you would just.
This one, they're saying this is fine because it's bounded and it's okay in between. It's just curvy things. This one is not good.
That one we would have to do kind of like absolute value, or we have to find it, or two things.
Yeah, kind of. Now you could take the antiderivative and find the area under the curve from here to here, because that doesn't have a problem, but you can't overlap that absolute value when you're taking the antiderivative. Yeah, very good. Very, very good. Very good. Very good. Okay. All right. So, yeah, you guys have a little bit of a lengthy homework assignment. I'm not going to be here tomorrow. Would you like for me to just say, work on that and we'll turn it in on, yes?
Yeah.
Okay, make sure you're working on it though, and so we can just go over whatever questions we have on Thursday and turn that guy in.
Are you not going to be here at all tomorrow?
No. I have our CIP teachers
Do I need
meetings
to
and
spend
stuff.
the next 2 periods doing my test thingies then?
Oh, shoot.
Because I won't be here Thursday and Friday.
Can you? Yeah,
Yeah, I'll talk to my teachers.
okay, perfect. Okay, all right, there you go. Bye, Libby and Angel.